My name is Tatiana Maida, and I'm a graduate researcher at the University of Wisconsin-Madison, and I'll be talking about spatial or temporal sampling, assessing diversity levels in a Borneo rainforest using bioacoustics. Biodiversity surveys are often restricted to spatial data collection of one taxonomic group in one season, which limits our understanding of biodiversity patterns. But what could we possibly miss by sampling over space only? Do different taxonomic groups respond to impacts differently or similarly? Using passive acoustic recorders, we wanted to answer this main question. What is the difference between alpha, beta, and gamma diversity of all vocalizing taxonomic groups captured by spatial and temporal sampling with and without selective logging? And we synchronously recorded all the sounds in a landscape at 15 mature forest sites in East Kalimantan, Indonesia, once a month for an entire year. So for this spatial sampling, we randomly selected 1 minute during the dawn and sampled this minute for all the 15 sites. For temporal sampling, we have a group of never logged forest sites and a site that was selectively logged for the first time during the recording period. And we sampled for these both temporal groups, a dawn and a dusk minute every month for a year for both temporal groups. And using these visual graphs that are organized by frequency and time, I manually labeled all the animal sounds in each 1 minute sample. And I used the number of different sonotypes or unique vocalizations as a proxy of species richness of birds, insects, mammals, and amphibians. I annotated more than 3,000 vocalizations, and birds and insects accounted for most of the annotations. Some preliminary results are that for birds, we found a similar number of sonotypes per minute for both samplings, the temporal and spatial sampling. So a similar alpha diversity, but sampling over time yielded a greater accumulation of different bird sonotypes, so a higher gamma diversity than sampling over space. And we found the opposite for insects. There was also no difference between the number of sonotypes per group, but sampling over space yielded a greater accumulation of different insect sonotypes than sampling over time. So when comparing the sonotypes captured by each sampling, we found a low overlap between the two samplings for birds and for insects. So for example, we found the rufous-tailed llama in both spatial and temporal, but we found the Borneo barbet and the great argus just in one of the samplings. So depending on the sampling method you choose, you will probably capture different species. Lastly, comparing the two temporal samplings, the selectively logged site in yellow had a lower accumulation of bird sonotypes and a higher accumulation of insect sonotypes over time when compared to the never logged sites. We concluded that even in a low seasonality tropical forest, the richness and composition of the vocalizing diversity vary greatly throughout the year. The complementarity from spatial and temporal sampling suggests that to truly understand the impacts of human activities on biodiversity, it is necessary to sample over both space and time. Thank you very much.